Well, hello out there again in remote learning land. Today's hot topic, we're going to talk about how pressure is related to winds. Yes, excuse me. Yesterday we talked about how pressure can help you predict the weather, right? If the pressure drops, low pressure tends to bring in storms. If the pressure is coming up, it tends to bring in clearer, sunny days. Today we're going to talk about how pressure relates to generating wind. Okay? Okay. Take a look at the seesaw analogy here. Different pressures on either side create a motion, right? You've all been on the seesaw as a kid. Well, high pressure air coming down would create an unevenness and it would start to move air. And that's what wind is, the motion of air. Okay? All right. Check out this satellite imagery here. Tell me if you can see which direction this hurricane is moving. See if I can get that to go there. There it goes. Which direction do you notice that hurricane spinning? All right, hopefully you saw that was spinning in a counterclockwise direction. I'll do that one more time. Check it out. Right, clearly you could see that rotation. I hope you could see that. Okay, classic counterclockwise swirl. In the northern hemisphere, storms will spin counterclockwise, and of course that's where we are. So all of our hurricanes and tornadoes will spin counterclockwise. That has to do with the Earth's rotation. We'll get into that later on. All right, so how do we describe this map? Well, these black lines, those are your pressure lines, your isobars. They connect equal points of pressure. Sometimes they'll make those circles. Sometimes they'll run off the map. But they are lines of equal pressure. And you could see what they're skipping by, right? 1004, 1008, 1012, 1016. Skipping by fours. And that's what's called a 4 millibar. That's the unit there, 4 millibar interval. All right? Gradient formula is the same, right? Front page of the reference tables. And you can calculate a gradient using this map and that formula. All right? It's the rate of change in pressure between two places. Okay. If you have a steep pressure gradient, the wind's going to blow fast. And on a map, you could see that when the isobars are close together. If you have a gentle pressure gradient, well, there'll just be a gentle breeze, and that's when the lines are far apart, like here or like here. Okay, if the isobars are far apart, it's not going to be a windy day. If they're like this, like they were last week, it's going to be a very windy day. Okay, make sure you're getting your notes down there. And wind likes to go from higher to lower pressures. Just like heat like to go from hot to cold, well, wind likes to blow from higher to lower pressures, right? It goes from high pressure to low pressure. And that results because the Earth isn't heated evenly, right? It's not daytime everywhere on Earth. So a part of the Earth has the sun, the other part is in night. The temperatures are different. Different temperatures create different pressures. And once you have a different pressure, the air starts to move from the higher to the lower pressure. Okay? The instrument we use to measure all this is called an anemometer. And the faster it spins, the higher the rating on the instrument would be. The wind vane is the classic rooster you see on the barn in the movies. It will usually point to the north. The anemometer gives the speed. So here you have a wind vane up top and the cup spinning around. It's called a cup anemometer, gives you the wind speed. Okay? This chart, please fill in with me here. So we have two different houses. We have house A, and house A is currently having low pressure, as you can see. The air is rising, so it's warm, it's wet. They're going to have rain. Okay, that's rising air by house A. Well, air doesn't just stay in one place, right? It's got to keep moving around the Earth. In another place, it's got to be a different situation. It'll be cooler and drier. It doesn't rain all over the entire Earth at the same exact time. So this place is having a cool, dry day. The air is sinking down, right? A higher pressure air sinks. And this whole thing will create this convection cycle. I hope that looked familiar to you. Once again, the wind blowing from the high back to the low rises up, you make clouds and rain, circles back around, and you get this convection cycle over huge parts of the earth. Okay? These diagrams at the bottom are going to simulate low and high pressure. I've put some bullet points in there. Please make sure you have them all. If you'll notice over here, the pressure is decreasing as I get toward the center. It's getting lower, so this must be a low pressure center, right? L for low. And the conditions affiliated with low, well, you're going to have that counterclockwise spinning, just like the storm we saw in the satellite image. Other things, other conditions, your bullet points, going to be warmer, more moist air. Obviously, the lowest pressure will be in the center. That'll be the worst part of the storm. Okay, like the center of a tornado, think about. The winds will converge. They come together. They converge to the center. Winds will also go counterclockwise, as we said. And as you go outward, obviously, the pressure will increase, right? You're leaving the storm. A couple of ways some students like to remember. LOCO, right? Low is convergent. Or LIC. Low is inward and counterclockwise. Whatever, helps you remember it. Okay. On the other side here, you'll see numbers increasing as we go in. So there's a high pressure center there. That's going to be a nice day, right? High is cool and dry. The air is not going into the center. It's going out. And look which way it's spinning, right? It's going the other way. It's going clockwise. The conditions are going to be exactly opposite these, right? It's going to be cool and dry, higher pressure in the center. The winds will move out, so they're not converging, they're diverging. They're rotating clockwise, all right? Pressure decreases as you go out. It increases as you go in. The exact opposite scenario of the low pressure, all right? Couple of other ways students like to think here. High die. High pressure is divergent. If you obviously don't do drugs, but if you do high, you're probably going to die, right? That's how they thought of that one. And the other one, HOC. High pressure is outward and clockwise. That's what that C stands for. High pressure is outward and clockwise. So hit pause if you need to make sure you get all these bullet points. Okay, for the summary questions, you know the deal. Refer to your notes if you need to. Figure out which ones are correct. And, of course, we will meet back in the meet momentarily to see how you guys did. All right? See you in a bit.